As the world's population grows, the quality of its soil is rapidly decreasing. Approximately 30% of the globe's land area is affected, and around 3.2 billion people depend on this land. The area most affected is the region south of the Sahara. What's causing all of this, Sharon?
Well, for example, soil loss, but also climate change and industrial agriculture, which damages the soil with artificial fertilizers and heavy machinery. But there are ways to stop this process and quote-unquote cure sick soil. The solution is a very special type of earth that's called Pt2 and can be made anywhere in the world. We had a look in Germany.
It's harvest time in this experimental garden. Entrepreneur Joachim Böttcher is pleased with the yield. These crops haven't been watered or artificially fertilized for 10 years. They've been kept alive solely through natural rainfall, and yet they're thriving. The secret behind this apparent miracle is a layer of Pt2 on the ground. The highly fertile soil mixture is based on an old indigenous formula from the Amazon region.
Roots need more than just moisture. They transport the nutrients and need very porous earth. If there's not enough air down there because the soil is too compressed or dense, they don't grow well. With Pt2, the soil is loose, airy and moist, and it contains nutrients and beneficial microorganisms.
Pt2, Portuguese for black earth, can be made almost anywhere in the world. Here it's mixed from locally sourced materials. In this village in the Frankfurt region, it's made with mown grass, dried leaves, the remains of mushroom cultivation and manure. The ingredients are then combined with a special mixture of charcoal, bacteria and fungus. This is covered and stored for 4 weeks to allow the mixture to ferment, converting the organic waste into fertile soil.
We can use a wide range of biomass types for our charcoal production. It doesn't have to be wood. We can also use things like straw leftovers from the harvest, even bones. A whole array of carbon-containing products can be turned into high-grade charcoal, and this charcoal is the basic ingredient of Pt2.
A look into the microscope shows why. Charcoal is highly porous, so it can store water and nutrients. The pores offer a breeding ground for microorganisms, which help the plants to absorb the nutrients. Others transform plant remains into humus and bind carbon in the soil, helping to protect the climate as well.
We'll have to feed over 9 billion people by 2050. That means we'll have to treat the soil differently. Pt2 offers us the chance to at least help farmers conserve and improve their soil at a locally sustainable level.
These agricultural experts from Morocco share the same goals. Agriculture plays a fundamental role where they come from. Here they can see firsthand how soil improvement functions in detail. That helps them find solutions for their own environmental problems.
And very dark, you see?
In general, our main problem is the intensification of agriculture, because it also leaves us with fewer organic waste products.
They want to use the charcoal-rich Pt2 in Morocco as well.
Once the ground is contaminated or depleted, it takes many years to recover. So we have to find a solution to tackle that problem. And the soil we've been shown here, the Pt2, is an excellent solution.
These Riesling vines weren't growing well anymore. Many of them were small and spindly. The ground was dry and depleted, so the vintner added Pt2 to the soil.
The thing is, we're here in an area where vineyards have existed for almost 2,000 years, without crop rotation, in principle an extensive period of monoculture. That definitely leaves some areas a bit worn out. The soil has to be reactivated. We can't continue like this for another 2,000 years.
The initial results are very promising. This ancient farming technique clearly has a bright future.